example 1b, we are going to be graphing the same parent function as we did in 1a over the same domain, but our translation is going to be a little bit different. So I'm going to go ahead and use those same 5 points because I still have my parent function of f of x is equal to x squared. So we have the point -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And that is my f. And just like I did before, I'm going to label everything that I know about f. So the domain of f is -2 to 2, as it's given in the directions. The range is bottom to top, so that would be 0 to 4. Again, remember, domain, we're looking for the x, range, we're looking for the y. And then the equation is f of x is equal to x squared. Now we're going to look at g. In this case, it says g is obtained with the translation 3 units to the right. So I would take all my points of f and I'm going to shift them over 3 points to the right. So this point over here, this 2, 4, is going to shift 1, 2, 3. It's now at 5, 4. 1, 1, 1, 2, 3 is going to shift to 4, 1. 0, 0, 1, 2, 3 is going to shift to 3, 0. -1, 1, 1, 2, 3 is going to shift to 2, 1. And -2, 4 is going to shift to 1, 2, 3, 1, 4. And then we're going to connect those, and I'm going to label it G. So with G, domain is our left to right, and this one does change domain. In the last example, my domain was the same, but this one, because I am doing a movement that is on the horizontal and not on the vertical, my domain is different. Now, the farthest left I go is a +1, and the farthest to the right that I go is 5. The range, which is my up and down, has not changed because this did not move any in the vertical direction. The lowest that I go is still a y value of 0, and the highest is a y value of 4. So my range here is still 0 to 4. Now with this equation, I'm not changing the y values, I'm changing the x values, which means I need to be acting on the x before I do anything instead of acting on the entire y value after I've already squared it. This is going to look a little bit different because we move to the right, but when we look at the equation, you're actually going to see a negative here. And that is because if we say that we were adding 3 to each of the x values to get g, that means that the g function is actually 3 less than the x values of the f function. So you would do the x minus 3 of f in order to get your g. I'm going to talk more about this minus on the next page, and we're actually going to look at some basic equations of absolute value and quadratic with their movement. So rather than just picking these numbers out, like I did with this x minus 3 in parentheses, on the next slide, you're going to see the explanations for where those numbers come from and why they are important to the problem. So here you can see the absolute value in quadratic. These are sometimes, they're not really standard form. I think that's how I have them labeled on the notes, but technically standard form, especially for quadratic, is something different. But these are forms where you can easily identify your h and your k values. H and k are extremely important because your h and k tells you what the middle of your graph is going to be. So for an absolute value, the h and k, that's where you're going to get that point of that v or the point of the peak if it's opening down. And for quadratic, that h and k, that's going to be the lowest point of that u shape, or it's going to be the peak of the mountain-looking shape if it's opening down. Instead of a y, you could have an f of x. The a's, we're not going to talk about those yet. That comes up more whenever we do reflections and dilations, which makes your graph wider or more narrow. But I want to focus on the h's and the k's with this. K, I started with first because K doesn't involve any switching. If K is a positive number, and you notice both of these have plus K at the end, if K is a positive number, your graph is going to move up. If K is a negative number, your graph is going to go down. Like in our first example with 1A, we were taking 3 away, so K would be a negative 3, so that's why that graph moved down 3 units. Now for H, and notice here I have if H is positive, it goes to the right, and if H is negative, it goes to the left. And you might be thinking, well, wait a minute, we had a movement to the right and there was a negative in the equation. And that's where you have to be careful, because in both the quadratic and the absolute value equations, the formula is x minus h. Because there is a subtraction in the formula, h is going to look opposite from the actual value. So if, for example, you had an h of a positive 4, in the absolute value equation, it would look like x minus 4, because there is, again, a subtraction in the equation. So you just have to be really careful with the h's, because the actual h values are going to look opposite than they do in the equation. And we're going to do a little bit of practice with that on the next slide. And notice I did put the caveat, h is opposite from the equation out in front.